Okay, guys, so today we'll continue with rational expressions. We're going to be doing everything that we've done so far um, and a little bit more because now we're going to have to multiply rational expressions. So we will still have to find the non-permissible values, we'll still have to simplify, but we'll have to do this additional step of multiplication. Okay, so that's the only difference. So for the starter question, I want you to I guess simplify this fraction. Again, it's a multiplication. So there's many ways of doing it. Because you guys have access to your calculator, it should not be too difficult for you. But while you're doing this, ask yourself this question. What would be the easiest way to do this question? And let me give you a hint. The easiest way will enable you to do this question without even using a calculator. Okay, so pause the video, try this out. But obviously I'm going to continue. So one way, right, the simple way is because we're talking about multiplication, right? We can simply multiply our numerators together and then put the answer, whatever the answer is, let's say 45, and then 15 times 25, so that's 250 plus 125, maybe 375, okay? So something like that. But you see, once you multiply, so I guess let me take a step back, okay? Because it's multiplication, you don't have to find the common denominator, okay? It's the same thing for division. When you multiply fractions or when you divide fractions, you don't have to worry about the common denominator. That's only for addition and subtraction, and that will be the focus for next week, okay? But here, because you're multiplying, that's one way of doing it. And now you can simplify this, but you see, simplifying at the end is always more challenging than if you simplify it at the beginning, right? So here, I don't know, maybe 5 would work, right? If you divide this by 5 and so on and so forth. So I'm not gonna continue. I mean, you guys can simplify this. If this is how you did it, it's fine. But let me show you a better way of doing it, okay? With numbers, it really doesn't matter because, we can obviously simplify at the end with the help of a calculator, right? But when it comes to rational expressions, right? Rational expressions have variables in them. So your calculator can really help you. So you'll have to go with the best strategy from the get-go, okay? So how do you approach a question like this? Well, the best way is to, again, break your numerator and denominator into a product of prime factors. What do I mean by that? Well, 5 is already prime, so I'm just going to leave it like that. But 15 is actually 3 times 5, okay? And both of them are prime numbers, so I cannot factor anymore. Times, right? 9 is just 3 times 3, right? I'm talking about this line over here. I rewrote that as 3 times 3. And the 25 is 5 times 5, okay? Now, the advantage of factoring at the beginning is that it will help you simplify the fraction um, from the beginning, okay? So, for example, I have this 3 on top. Now, you see, everything is written as a product, okay? We don't have, and you know what? I'm just going to change this times to a dot as well so that I'm consistent with my notation, okay? So, because everything is written as a product, we can start canceling things off, okay? Or whatever you see on the top, that's repeating itself at the bottom, okay? So, and when it's multiplication, guys, remember, you can actually extend this fraction symbol. So it's essentially like whatever you have on top and at the bottom, they're all together, okay? I'm not going to do that, but that's one way of viewing it. I'm just going to write it this way, but what I'm going to ask you to do is just see what you have in common at the top and at the bottom. So as you can see, this 5 over here can cancel out with this 5 because 5 divided by 5 is just 1, okay? Same thing with this 3. This 3, if you want, can cancel out with that 3, okay? So that's gone. So again, because the 5 and the 3, everything on my left-hand side got canceled, that means I'm only left with 1 over here, right? So this is just the 1, because everything got canceled out, okay? So, and I don't think there's anything else that can be canceled out. So this turns out to be, so if you want that, if it's really confusing you, you can just put 1 on the top, 1 at the bottom, okay? So that you can easily multiply now. So 1 times 3 is just 3, and then 1 times 5 times 5, that's just 25. Okay, so this is 25, and I'm just multiplying this by this one over here. Okay, so this is your answer, and as you can see, it's really easier to simplify. Let's say if you did not have a calculator, right? Because with rational expressions, your calculator cannot help you. So it's way better to simplify at the beginning than if you did that at the end. At the end, it would also work, right? So I think if I'm not mistaken, we got 45 um, over, um, I think it was 375, but let me just use my calculator now. 375, right? So I don't know if this is divisible by, well, let's just divide by 5. So if I divide both of them by 5, this becomes 9, right? And then this becomes 375 divided by 5, 75. And then you can divide this by 3 again. So you get 3 over 25, okay? Um, but you can do this. You can do this additional steps at the end, right? So divide by 5, divide by 3. So I guess we could have just divided by 15. But anyway, what I'm trying to tell you is that this step will be almost impossible to do with rational expressions, okay? You will have to rely on this method over here, okay? Because we haven't taught you how to, factor like um, things that have exponent 4 and stuff like that. Okay, so it's just better to factor at the beginning. I guess that's the point that I'm trying to make. So that's what we're gonna do. Okay, so using this logic, I know this is a simple question. We're gonna extend this and apply this logic to slightly more complicated questions. Okay, so what if you get a question like this? Okay, what if you get a question like this where you have to multiply and simplify? Okay, so write your answer in the simplest form. So first thing you need to do is find the non-permissible values, okay? Because if you you could, well, first thing I guess you should do is to factor and then find the non-permissible values because they will um, be a lot easier to find if you factor your denominator, right? Because right now we don't have a product, so it's hard to tell what values will make my denominator equal to 0, right? Um, so if you want, I guess the first step would be just factor everything out. Okay, factor everything out. To find the non-permissible value, you only have to factor the denominator, but I'm gonna factor everything, um, because I will have to do that eventually to simplify, right? So, but if the question was just find the non-permissible values, then don't factor everything, just factor the denominator, okay? So let me just factor everything. So let's start off with this numerator over here. So because see, in most of these questions, your coefficient will be 1 so that you can use the shortcut, okay? So the factoring should not be too bad. So for this numerator, right, you're looking for two numbers that multiply to minus 12, right? And they have to add up to minus 1. Okay, so maybe 4 times 3, right? 4 times 3 looks like, again, if you're not good at finding combinations, start with 1 and 12. That's not going to work. Then do 2 and 6. That's not going to work. And then 3 and 4 will work. Okay, so because my sum is negative, that means the bigger number has to be negative. Okay, so there you go. Okay, so minus 12 and then minus 1. So that means these are my this is because I can use a shortcut here, right? So this is what I'm gonna do. I'm gonna put a and then put the first value, which is minus 4, right? My variable is a, and then put a, my second um, combination, which is 3. So but it's positive, right? So I'm gonna put plus 3. And then denominator is easy to factor because it's, when you have two terms separated by a minus sign and both of them are square numbers, it has to be difference in squares, right? So you take the square root of the first term. So that square root of a squared is just a plus the square root of the second term, right? Which is 3. And then you rewrite that with a minus sign, okay? So you rewrite that with a minus sign, okay? And then multiplication, right? Multiplication. Now let's factor the second numerator. Okay, so again, we're gonna, go with product sum. So maybe let me just put that over here. So we are looking for two numbers that multiply to 1 times 3, that's 3, and they have to add up to -4, okay? And this one's really easy because the only way that you can get 3 is by multiplying 1 and 3, right? So 1 and 3. But then because, your sum is negative, so both of them have to be negative, okay? So negative, negative. So here, right, this is your first combination, this is your second. So you're just going to put a minus 1 and then a minus 3. Make sure you're putting brackets, right? Because now you have a multiplication. Now this one over here, some of you might be tempted to use difference of squares, but that's not what you have to do because you can take the square root of a squared. Yes, you can also take the square root of 4, but you cannot take the square root of a, okay? Because then you're going to get square root of 8. So as tempting as difference of squares is, there's actually something easier that you can do. So whenever you have a quadratic, right, and only two terms are given, then it's really easy to factor because you see the a is repeating itself. So all you have to do is just factor the a. Okay, so this will just become a. If I factor a, then you have to ask yourself, what do I need to multiply this a by to get a squared, okay? And the answer is a. And then what do you need to multiply this a by to get minus 4a? So the answer is minus 4, okay? So I guess what I'm trying to tell you over here is that if you can factor the whole thing without using any fancy techniques like difference of squares or product sum, then just factor, okay? So start by simple factoring, right? Put something, if you see something in common, then factor, okay? Once you've factored, maybe you can factor again, so be careful. I think that's what will happen in the next example. But anyway, okay, so this is what we have. And now using this, I know what my restrictions are, right? Because now my denominators have been factored and I have to make sure that my denominators do not equal to 0. Okay, so that means looking at the first term, I know that a cannot equals 2. Um, a cannot equals 2. So again, let's just put them in increasing order. I'm going to put everything all together. So over here, right, I know that a cannot equals to -3, -3. And then the next one, this is +3, but let's just hold on to that. So this is +3, this is 0, and this is +4, right? So I guess the next one in increasing order would be 0, and then after that it would be 3, and then it would be 4, okay? Because if a equals to 0 over here, then this thing will become 0, and that's a problem, okay? If a equals to 3 over here, then 3 minus 3 is 0, so this whole thing will become 0. So that's a problem. And over here, if a is equals to 4, then the whole thing will become 0. Okay, so those guys were the problem. And how was I able to figure out the restrictions? Again, just by factoring the denominator. Okay, so you didn't have to factor the numerator, but I did because now um, I can at least do the next step, which is to simplify, okay? But if someone is asking you just to find the non-permissible value without simplifying anything, then you don't have to factor everything, just factor the denominator, okay? So because I have this, now I'm going to use the same logic as I did with the starter question, right? So things that I see repeating themselves, I'm going to cross them out. So I have an a minus 3 over here, a minus 3 over there, they cancel out, right? Because a minus 3 divided by a minus 3 is just 1. Then you have an a plus 3, they also cancel out. Oh, and then you have an a minus 4, a minus 4. So this also cancels out. So the only thing that survives over here, guys, is this, right? This a minus 1 and then this a. So your final answer is just a minus 1 over a, okay? So again, as you can see, this kind of forces you to do everything that we've done so far plus understand how multiplication works, right? And I've shown that to you in the starter question. Okay, so if you're finding this confusing and you skip the starter question, go see the starter question, and this will all make sense. Okay, um, so the logic, right, with math is always consistent, right? So whatever we did with numbers, whatever was working with numbers, we're gonna do the same thing. With variables now, okay, with the expressions, right? Rational expressions if you want, okay? So same logic, right? But as you can see in this answer over here, my only restriction is that a cannot equals to 0, okay? So you've lost these three restrictions, okay, which will always happen when you simplify. So make sure you find the restrictions at the very beginning as soon as you factor your denominators. Otherwise, you're going to lose a lot of them, okay? So let me just make this a little cleaner, and then I'll go on to the next question. Okay, so next one, your turn. So maybe pause the video, try doing question A, and then just try doing question A and B if you want, if you feel comfortable. Um, and then, compare your solutions to mine. I guess that would be um, a nice way of doing this, but maybe it's too soon for some of you to try those questions. So in that case, I'm just going to ask you to not pause the video if you're not feeling comfortable, and then just observe what I am doing over here. Okay, so question A is really easy because as you can see, everything is already factored for you. Okay, so you already have um, everything in here written as a product, right? Numerator as a product, this is a product, and this, this is in the simplest form. Okay, so you cannot factor that anymore. So this is fine. So let's start off with the restrictions, right? So the restriction over here is that in this denominator, right, 2 and pi are constant, so they're not going to change. So my first restriction is that r cannot equal to 0, right? And my second restriction, looking at this denominator, is that d cannot equal to 2, right? Because 2 minus 2 will give me 0. And again, if you're having a hard time finding those restrictions, you can always set your denominator, right? D minus 2 equals to 0, and this just solve for your variable. Okay, in this case, it's d, so d is equals to 2. So that means d is equals to 2 will make my denominator 0, so I have to make sure to remove that value, so restrict it. Okay, that's why that equal sign changes into an not equal sign, or I don't know, I forgot what that's called. Okay, so when it's not equal to something. Okay, so anyway, um, so one thing that I'm going to be very, very clear about, okay, is some of you might be tempted to cross out this D with that D, okay, because that's um, looks kind of like what I did in the previous question, but see, there is an issue if you do that, okay? What I did in the previous question is something very similar to that, but I had products on my everywhere in the numerator and the denominator, okay? Here, this is not a product, okay? In this question, d minus 2 is not d times negative 2. Okay, so you cannot cross the d's out. Okay, so if you had minus 2d in your denominator, right, instead of d minus 2, if you had minus 2d, now this is a product. Okay, then you could have canceled this d with that one. But here it's not a product. Okay, if it's not a product, then you cannot cancel stuff out like that. Okay, because that's not what I told you to do. Okay, so always cross out the products. Okay, now what you can cross out is the 2 pi r, right? So the 2 cancels out the pi and the r, with the 2 over here, the pi over here, and the r. And the other stuff will just remain. Okay, so the answer to the first question, I guess, is so question A, right, just simplifies to, actually, you know what? Question A, let's just do this. So this just simplifies to, let me bring this down with an arrow. So the D survives on top with the H, right? And then you have D minus 2. Okay, so this is it. Okay, so again, don't be tempted to simplify this D and that D because you don't have a product in your denominator. Okay, it's actually a subtraction. Okay, so um, now for the second question, again, I would start by factoring stuff first. So question B, on top right, you have minus sign, and then you have two square numbers. So I'm going to apply difference of squares. So this is just y plus 3, right? So take the square root of the first term plus the square root of the second term. So that's y plus 3. And then rewrite that with a minus sign, okay, over. Now you see you have r cubed minus r. So the first thing that I've said that you always have to aim for is, can you factor the whole expression? Yes, I can. Okay, if I factor the whole expression, then I'm going to get r times r squared minus 1, okay? And this, guys, right, maybe not so obvious, but it's a difference of squares. So you can simplify this a step further, right? So this r still remains here, and then you apply the difference of squares to this. So square root of r squared is just r, square root of 1 is 1, and then so this becomes r plus 1, r minus 1, okay? So you have r plus 1, r minus 1 for your denominator, okay? And I've shown you the work over here. Now, times, right? So as tempting as this is, right, you might think difference of squares, but it's not, because again, you cannot take the square root of r, okay? So whenever you see the variable repeating itself, then the best thing that you can do is just factor. So I'm going to factor the r. So that leaves me with r minus 1. Now, I cannot use difference of squares for this guy. It's because it's not r squared, okay? Because if, like, over here, I had r squared, so I could take the square root of r squared. Now, in this, right, in this example, I have r minus 1. So I can't really use difference of squares. It's not going to help me. I could. It's not going to be wrong, but if I apply difference of squares to this guy, then I'm going to get square root of r plus 1 times square root of r minus 1, but that just makes it look even worse than it initially was, right? So you wouldn't want to do that, okay? So when you simplify, right, your goal is to make it look nicer, not uglier, okay? um and then finally, my denominator is just y plus 3. Okay, so now I have everything that I've done everything that needs to be done, I guess. And if you want, you can just put brackets like this. Okay, so that means they go together. And if anything, it could have helped you with this confusion over here, right? So when you put the brackets over here, that means the d and the 2, they go together. You cannot just cross out the d's. Okay, so if I think putting the brackets together would help you visualize this a little bit more. And now I have everything that I need, right? So again, I didn't have to factor the whole thing if I was looking for the non-permissible values or the restrictions, but I'm doing that because I want to kill two birds with one stone, right? So let's just focus on this denominator. So I know that my non-permissible values is that r cannot equals to, again, I'm going to go in increasing order. So it's minus 1 over here, right? Minus 1 for this guy over here. Minus 1 and then 0, right? And then 1. And also I know that y cannot equals to negative 3, right? Because negative 3 plus 3 will make my denominator 0. So these are your non-permissible values. Now let's simplify. Okay, so let me just get rid of all this. So how do you simplify? You simply find the terms. So you can only cancel out the terms that are on top of the terms at the bottom, okay? So this r, for example, over here is on top and this one is at the bottom, so they will cancel. If they're both on top, then you cannot cancel like that, right? Because again, remember, the only reason why canceling is working over here is because we're essentially dividing it, right? So r divided by r becomes 1. But when we're multiplying, 1 is redundant, right? So you don't have to write the 1. So that's why you just kind of like have to ignore it, right? So whenever you multiply something by 1, the value doesn't change, okay? So y plus 3 will cancel out with y plus 3. R minus 1 will cancel out with r minus 1. And that is it, okay? So this will simplify too. My final answer is I'm going to have y minus 3 on top. If you want to keep the brackets, you could. If you don't want to keep the brackets, then no problem. Um, and then r plus 1 in the denominator, okay? So r plus 1. I'm just going to make this look a little nicer. So r plus 1 in the denominator, right? So only these guys, they were able to survive. And as you can see, if you find the non-permissible value over here, then the only non-permissible value in this expression is this, okay? You've lost all the other ones, right? Which is why I find the non-permissible values at the very beginning once you've factored your denominator, okay? So at this stage, okay? And that is it for today, guys. I didn't want to make it too long, but what I want you to do is I want you to try doing, so I know I'm giving you a lot of homework here, 1, 2, 5, and 7. So I'm only going to be releasing 2 videos this week, and both of them hopefully will get posted on Monday. But Wednesday, it's your free day to again finish the homework, the questions that you were not able to do. Okay, so I'm giving you an extra day to work on this, all the questions. So I want you to do every single question. What do I mean by that? I want you to do A, B, C, D, whatever, as many as you can, because this stuff will only become um, you know um, natural to you, right? This simplifying business will only become easier, or that it will make a lot more sense when you practice. Okay, I can do a lot more questions than this, but I think I've given you the general idea. Now you just need to practice, and math requires a fair bit of practice. Okay, so then it will come to you more naturally. Okay, so please do try to do every single question, and again, if you are not able to do so, then Wednesday you will have the time to do that, and then on Thursday I'll hold office hours to answer any questions that you may have. Okay, so this week the focus will only be on multiplication and division. Okay, and the week after we're going to do addition and subtraction. Okay, so that is it, guys. Thank you so much.